Hi guys, Mr. Shaw here. Thanks for coming back and actually watching these videos. What I'm going to do today, since it's day 3 of Introduction to Engineering, I'm going to walk you through basic stuff we're going to do in advanced components. I'm going to talk to you a little bit about advanced components. This is only going to be like an 8-minute long video at max. Whenever we hit 8 minutes, I'm going to cut it off. That way you guys don't have to listen to me drone on and on. Homework for tonight is just going to be a series of questions I'm going to put on Google Classroom. It's literally going to be 2 questions that you have to go through and answer. Not too bad, just basically 2 sentences you're going to ask, just making sure, or answer, just to make sure that you're actually watching through these videos. For those of you guys that haven't already, remember there are a couple of assignments that we had earlier, so just please make sure to go through and do those assignments as well. So let's look at just a couple of things. So resistance, if we remember what resistance is, we have 3 major things when we're dealing with electricity. We got voltage, we got current, we got resistance. And typically when we're dealing with these 3 values right here, all right, remember voltage and current are tied together by this resistance. The more resistance we have, the less that current's going to flow, even if we have a high voltage. All right, one of the reasons why when we have static electricity, there's such a high resistance that our current stays low. Because if you think about it, when you get shocked but like a doorknob or something, you're looking at thousands and thousands of volts. But it's just a very small little current because of the resistance we have in our bodies and in the air itself. Now, a couple things that actually affect resistance. First off is the idea of length. All right, think about a cable. All right, most of the time with cables, we've been assuming that we don't have any loss of basically current from it. Basically, the resistance is almost nothing. Well, as that length gets longer and longer, especially with transmission wires that are going to be hundreds of miles long, you're going to have resistance, and you have to take that into account. Another thing is cross-section area, and this is another thing that has to do with power lines. When you're dealing with power lines or power transmission, when all of a sudden you start increasing the amount of current that you have to make the size of it enlarge as well. Reason behind this, if you take a look right here and here, you can see right here I have 2 circled lines. This one right here is a high current. This one down here is a low current. All right, if we did not increase these sizes, the resistance would be so much that the cable would start to heat up. And when it starts to heat up, that's when eventually it starts to melt. And when it melts, that's also when you have something bad happen that's called fire. All right, so by enlarging the size of those cables, we drop the resistance, we allow the current to go through there freely, and we have less loss of power and less of that change from electrical energy to thermal, which is bad. And here you can see another example down here, transmission lines. As we get longer and longer, we're dealing with more and more resistance. Another couple things, factors affecting resistance. So first off, we got temperature. All right, if it gets hotter outside, you're going to get more resistance. This is one of the reasons why on very hot days, you start dealing with a lot of problems with power loss in the lines, because you're going to get more resistance on there that actually makes the lines get warmer. This is also one of the reasons why, if you remember when we talking about cable sag, that's how much a cable sags between the 2 towers. On those really hot days, the cable sag actually goes down even more, making it more imperative, all right, that you have all the vegetation cleared out underneath so you don't lose something. And last but not least, the type of material. So here's the thing, electricity can go through anything, all right, even something that's called an insulator. We have 2 main types of what we have electricity going through. We have conductors and we have insulators. Insulators generally don't like to let electricity go through it. In other words, they have a very high resistance to electricity. Conductors, on the other hand, have a very low one. Very low meaning it's going to be very easy for that electricity to flow through it. Very little resistance. Now, just because something's an insulator doesn't mean electricity can't flow through it. So let's take a look at a couple things right here before I get into that. This is a graph of temperature versus resistance of wires itself. You'll notice as we're going up and up and up, we're starting to see more resistance. All right, there's our line right there. And here we can see we've got a couple of ideas. So we have the conductor on the inside, in this case copper. We have this insulating material on the outside. All right, a lot of times they're made out of different materials, sometimes rubber, sometimes nylon, could be many different things. Now here's the thing, that electricity can flow through that insulator on the outside, But in order for that to happen, you have to have a very high voltage to overcome the resistance that is inside that material right there. It's the reason why if you have too much voltage going through a wire, all of a sudden you get sparks that jump. All right, think about air, think about lightning. So when we're dealing with lightning itself, lightning is coming from miles and miles into the air and jumping through air. And remember, air is a really good insulator of electricity. It doesn't like to let things go through it. So what's going to happen is as that voltage builds up so much, it overcomes how much resistance there is there and allows it to travel through there. And what's happening is because there's such a high resistance, as that electricity jumps through the air, it gets super, super heated because of the resistance and the thermal power being let off. And that's why you get the thunder and that's why you get the lightning, because it's just superheating that air. Basically, you're getting what we call an arc flash and an arc blast, which we're going to talk about later on this week. All right. Now, let's go on to here. We're going to be talking about this more tomorrow. I'm probably not going to go much further because we're running out of time already. But let's take a look at some of the things we're going to be talking about. So we're going to be talking about some advanced components beyond resistors, stuff like capacitors, stuff like diodes, fuses, circuit breakers, stuff like that. And I'm going to leave us off today. I'm going to actually play you a video. This is an industrial strength capacitor. All right, so industrial strength. So this is using transmission wires. And what you're going to see is these guys have charged up this capacitor. And for whatever reason, they decided to put a watermelon in there. So you can see right here, they're sticking the watermelon on one side. These cables are actually just typical ground cables. They're ones they use in Europe. So they're putting on either side. Again, I suggest if you do come across some really, really large capacitor like this, don't do this unless you really know what you're doing. So basically, hopefully it'll be years down the line. All right, so here you can see on the off side, this is what they've been charging it off with. You got this electrical wire going off there. This is what they're also going to pull it with. So again, this is used in the transmission of power. And that is why you don't screw around with capacitors. Capacitors can be extremely, extremely dangerous because of the amount of charge that they hold. Imagine that if you're a person and you're actually touching these two ends of these electrodes coming out of here, and all of that energy is released all at once. If that was your hand, you basically have no hand. All right. So that's where I'm going to stop for today. Again, you guys will have the assignment on Google Classroom. I guess just a couple questions. Go on there. Thanks, guys, for listening, and I'll talk to you later.